My name is John Ecclesine. I've got a problem here. It's common to all cars. Hiding underneath this once beautiful paint job is one of the biggest headaches known to all car guys, and it's rust. Left unrepaired, rust can eventually destroy a car. What appears to be small blisters here at the bottom of this door is what's commonly called body cancer. And there's only one way to properly repair body cancer. That's to cut out the entire section, replace the panel with new metal. Often, on older cars, a complete replacement door skin can't be purchased, so I have to use a patch panel. These can be bought ready-made in some cases, otherwise they'll have to be fabricated. I'm going to show you how to install a patch panel on this 57 Chevy Bel Air door. This technique can be applied to virtually any car made, even the older sheet metal over wooden frame cars, providing that the wood has been stripped away from the area to be welded. I'll be using an oxyacetylene welding outfit to hammer weld the patch panel into place. Later on, I'll discuss an alternate method of welding, and there'll be a short demonstration with a MIG welder. The hammer welding sequence will be presented in 3 steps. Step 1, inspection and preparation of the door. Step 2, removing rust and treating metal. Step 3, fitting, hammer welding, and metal finishing the patch panel. These are the tools I'll be using for step 1. If you want to study the tools shown here, use the freeze frame on your video player. The first thing I want to do is look at this door real close, both inside and out. It appears to be rusted at least 3 inches up from where the door skin flange is folded under, all the way across. Before I strip this door, I want to make a quick sketch of it, showing the exact overall dimensions. Both height and length at 2 points each. This will be real useful later on after I weld the patch panel for checking the overall dimensions of the door. A lot of guys are so anxious to cut and weld that they overlook some quick preliminaries and end up with a disaster when the door doesn't even come close to fitting the opening from which it came. I'm going to make 2 templates of this door before I cut into it, showing the overall shape it has. So when I'm welding the patch panel on, I got something to check it to. Chances are it's already been repaired once or twice the wrong way. That's why it's rusting through again. But since it does have the right shape when I sight down it, I'm going to make these templates before I strip off the paint. There might be as much as an inch of plastic filler under here for all I know. For the first template, I'll use this piece of cardboard I got from a bicycle packing box, out of a bicycle box dumpster actually. I'll clamp it to the lower edge of the door here, these paper clips. Flip the door over. Okay. Next, I'm going to trace the entire edge of the door from the inside with a pencil. Make sure you do a good job here, because you're going to be using this template several times later. I'll cut the cardboard out on the line as close as I can with these tin snips. I don't want to use my good tin snips when I cut cardboard because it'll dull the edges. But a good sharp pair will do the job. The height I'll make this template is determined by this reference line, which I've scribed on the door here, 16 inches up from the lower flange. I used a metal straight edge, clamped it at both ends, and used a metal scribe. Make sure to put your reference line location on your diagram, so later on you can refer to it and make sure you know where it's at. Since no door is flat, when I hold it straight, I jump against it. I've got to make some type of template which will show the contour this door has. So I made this template right here. So later on, when I'm welding, and after I'm finished welding, I can check the contour and be certain that the door has the proper shape. Otherwise, it'll end up too flat. You can't just eyeball it. A lot of guys do, but this is really the way to get it real close. The way I did it, I took 4 horizontal strips, held them up against the door, and with a pencil held flat against the door, trace a line. This will give you the shape of the door. And you trim right on the line here. And then with these divider sections I got from a box at a liquor store, I take the 4 strips I've cut horizontally, hold them in place, and with a hot glue gun, just glue them in place. A third hand is real useful here if you can find someone to help you out. This may seem like an awful lot of work, but when you're finished welding, and while you're welding, you can hold this up against your door skin. Note that it's 2 inches below my reference line for checking. And I can look in the back and see what kind of how close I am to having the shape that the original door had. That way you can be assured it's not going to be too flat. If you try to do it by eye, it's just, you're guessing. Now I'm going to compare the shape of the patch panel to that of the door skin. Too often, ready-made patch panels are just a flat piece of sheet stock with a flange broken in at the bottom, if you're lucky. I wasn't so lucky in this case, as you can see from these 3 photos. I took this picture of the patch panel before I reshaped it. The manufacturer had rolled the edge in with a bead roller and completely missed the correct shape that the lower rounded corner should have. Using template number 1, I transferred its shape with a silver pencil onto the patch panel. Next, I flattened the corner out with a hammer and dolly. The new metal works very easily. Then I folded the flange over at the scribed line with a pair of pliers and finished up with a round dolly, carefully working the metal to roll it to the edge. The whole procedure took 15 minutes. Since no door is flat, the patch panel has to be shaped so it has a slight roll in it horizontally before it's welded. Shaping the patch panel can be done with an English wheel, a pneumatic plenishing hammer, or an electric power hammer, providing one has access to them. But since most car guys don't, a simple rawhide mallet and a heavy log or a sandbag can be used for the shaping. I started the horizontal roll in this patch panel by sliding it back and forth over the edge of this workbench. Apply downward pressure equally as you slide the panel from side to side. Then I finished up with this rawhide mallet on the sandbag. Make sure you don't use a body hammer here, since it'll tend to dent and stretch the metal. It's time now to strip all the paint off the door. An automotive grade paint stripper will do the job. Make sure you wear a face shield and rubber gloves when you do this job. Now that the door's been stripped, look at this mess. Plastic filler's been stuffed in these holes. Unfortunately, a lot of so-called rust repairs are done this way. Looking at the inside of this door, I can see that the rust damage is a lot more extensive than I originally thought. So I'm going to play it safe and cut it up in this area. Now you may be wondering why, with this size patch panel, which is pretty large, I don't make my cut line right here where the molding holes are and use that area to my advantage when I'm hammer welding. Well, ordinarily I would. In this application, I want to make it as useful to everyone as possible, so I'll make a cut in this area. I'm going to play it safe and cut the door 12 inches up from the lower edge. I'll use layout blue and a spray can, and then scribe a line after it dries. I've clamped the straight edge 12 inches up from the bottom. With this awl, I'll scribe the cut line. Then I'll measure up 16 inches and re-scribe the reference line. After that, it'll be time for step 2. These are the tools I'll be using for step 2, removing rust and treating metal. Be sure to always wear the proper eye, ear, and hand protection. I'm removing the door skin. Be careful to grind just till the metal separates. Otherwise, you'll grind away at the inner door structure, which the flange is folded over. Notice the rust and dirt dropping out as the door skin separates. I'm being careful not to grind above the cut line. Use a fine file to finish the separation at the cut line. Now I'll drill a hole and use an electric shear to make the horizontal cut. Observe that I'm cutting 1/4 to 3/8 inch from the cut line. I could also use a saber saw to do this. The metal in the cut area is still good, healthy metal. Obviously, the worst of the rust is at the lower section of the door skin, where dirt and mud has accumulated and caused the metal to rust through. It is important to get the final cut as straight as possible for easier welding, so I'll use a sharp pair of aviation tin snips. At the ends, use a die grinder with a slitting wheel or a hacksaw. But again, take care not to cut into the door structure. I'll flatten out the rough edge left by the tin snips with a hammer and dolly. Tap gently to avoid stretching the sheet metal. Use a fine file to deburr the edge of the sheet metal so you can get the best possible fit up of the two panels for welding. Notice the weight of the door is propped on the 4x4 and not on the unsupported door skin. The folded over remainder is removed with a small chisel and the factory spot welds are ground away. If the spot welds don't separate easily with the chisel, carefully grind the spot weld area away. It will turn dark blue right before it separates from the inner door structure. There's no sense in putting a new panel over this rust, so I'm going to sandblast the rust away and repair any rusted sections before going on. After I sandblasted the door, I treated it with metal prep, which is a metal etch. Then I primered it with zinc chromate. You can also use zinc phosphate primer. I've never had any trouble at all welding with this type of primered metal. Now it's time for step 3. These are the tools I'll be using for step 3: fitting, welding, and metal finishing the patch panel. Okay, looking at my diagram, I see that I made the cut line 12 inches up from the folded flange. So on the patch panel, I measured up 12 inches from the folded flange and scribed my cut line. Here again, I'm using aviation tin snips to cut as accurately as possible right on the trim line. I've trimmed the patch panel to the correct shape and size. Around the edge where the flange is, I've drilled and deburred 1/8 inch holes 6 inches apart so that it can be folded over and plug welded to the inner door structure. I've primered the back with zinc chromate primer. I'm going to hammer weld these two panels together using no filler rod. Some of you may be wondering why I won't be using a filler rod when I hammer weld. Well, whenever possible, I prefer to fuse weld. Here, I'll show you why. Here's a panel made of same gauge sheet metal as the patch panel. I've cut it down the middle and hammer welded it together using no filler rod. The thickness, using a pair of dial calipers, of the sheet metal panel is 38 thousandths. The thickness of the weld where I fuse welded it and hammered it reads 36 thousandths of an inch. That's 2 thousandths of an inch difference in thickness. I find it's just as strong as using a filler rod, and it's a heck of a lot easier. The secret is you got to fit the two panels together real close before you weld them. Not too close or they'll overlap when you put the torch to them, and then you can't properly hammer weld them. On this particular door, there wasn't enough access through the back for me to get my arm in a dolly. So I cut this horizontal section out with a saber saw. Now I can get right in there. Then I tack welded these 3 diagonal pieces in to keep the door from twisting while I'm welding it. After I'm done hammer welding the 2 panels together, I'll cut this angle iron out with a die grinder and weld this piece back in. I won't hammer weld it. After I finished folding the flange over and hammering it, it'll be time to weld. I won't plug weld the flange yet. That'll be the last thing I do after the patch panel is hammer welded in. In order for me to be able to tack weld the 2 panels together, I made up these special vice grips. I used an extension spacer block made out of exhaust tubing. On the end, I've got a piece of 3/4 by 1/8 inch strap iron. The edges have been deburred so they won't dig into the sheet metal. They'll sandwich the 2 pieces together real nicely. This piece of strap iron welded to the spacer block, plus the combination of this wooden block here, will keep the weight of the vice grips from raising up the heated metal when I put the torch to it. If I didn't have that strap iron and the spacer block at the lower edge, as soon as I put the torch here, the weight of the vice grips would just raise this right up and stretch the metal under and over where they're clamped together. The door has been securely clamped to these sawhorses. It can't move. I placed 2 wet towels 2 inches away from where I'll be welding to control heat transfer. I'll start my tack welds at the center and alternate from side to side until I've worked all the way out to the edges. I'll never start at the edges and work in towards the center, otherwise you'll end up with a big bubble here. I make my tack welds 1/4 to 3/8 inch long. While I'm tack welding, I've always got a filler rod ready, just in case the metal starts to burn away rather than to fuse together when I put the torch to it. The torch tip size I like best for hammer welding is size 00. For gas welding, I wear these thin leather welding gloves, and we use a 1/16 inch copper-coated steel gas welding rod. The acetylene regulator is set at 5 pounds pressure, and also the oxygen regulator is set at 5 pounds pressure. I'll start with a tack weld in the center. 1/4 to 3/8 inch long is fine. I use a soft neutral flame for all the gas welding I'll be doing. I hammer the tack welds. I tack from side to side until I have a series of welds 2 inches apart. The alternating cuts down on heat distortion. After 3 tack welds, it's time to check the measurements again. From the reference line to the bottom, 16 inches. 16 inches also. It's still in alignment. I'll alternate tack welds until I have a series of welds 2 inches apart all the way across. This reminds me, I've got to stress eye safety when hammer welding. I didn't wear my goggles when I first started, and I'm real lucky that a piece of hot slag didn't land right in my eye. Notice the small weld bead. I'll use the 2 templates as a gauge to check the shape of the door as I weld. Notice the slight gap between the second template and the sheet metal. I'll have to be careful from here on not to overshrink the sheet metal. You have to sight down the weld seam as you work. This is how you make sure you're keeping the panel under control. With practice, you'll be able to tell where the metal is going to go before you even place a torch to it. One of the problems I've encountered with this particular patch panel is that it isn't wide enough at the lower flange to securely grip the inner door structure, and it keeps jumping off. So I've had to tack weld it in 3 spots with a MIG welder along the bottom. You might encounter small problems like this as you go along. You have to take care of them right away before things get out of hand. In this front hinge area where the reinforcement is, I can't get in there with a regular dolly, so I have to use this special dolly, wedge-shaped dolly, as you can see in this diagram. I'll finish welding now. Remember, when you're hammer welding, be sure to pull the heated metal into the weld. Don't just flatten it. I'm actually shrinking the weld when I hammer it. Keep the towels wet. A wet sponge can be used at times to additionally shrink the weld after hammering, but don't over shrink. I'll make alternate welds 3/4 to 1 inch long. Any more than that and I'll lose control of the metal or blow a hole. I'm at the end of the panel here. I can't fuse weld. If I did, I'd end up with a ditch where the flange fold is. So I'll use a filler rod weld. Later I can file the filler rod weld at the door's edge. Then I'll move back and repuddle in the weld before hammering it. Now you can see why I went to the trouble of making the second template. The door in the center section is much too flat. It's from over shrinking it while I hammer weld. Looking on the inside, as it gets away from the weld, the template shows that it does conform to the right shape. So I know that I only have to work the metal in a weld area to bring it up, just about 2 inches up and 2 inches below. really just about to where the towel's extended. That whole area is a little bit low. I cut out the horizontal braces on the back of the door so I can use the plenishing hammer. I'm pulling up on the plenishing hammer to bring the low areas up. Since most car guys don't have a plenishing hammer, you could also metal finish the weld area with the tool shown here. Here I use a comma dolly against a flat dolly to bring up the low spots. This is a pick hammer against a shrinking dolly to cold shrink the metal. Tap lightly or you'll stretch the metal. I'm working the low areas with a half-round slap file. A rawhide mallet against the dolly will additionally cold shrink and hand plenish the metal. Finally, a body spoon will hand plenish the weld area. The objective is to get the weld area as smooth as possible, so little or no body filler will be needed. Looking at the inside of the door, notice the good weld penetration from fusion hammer welding. I've plug welded the 1/8 inch holes on the inner flange with a MIG welder. These could also be brazed, but be careful to avoid warpage. Where the patch panel meets the original door skin and is folded over, I've welded it with a filler rod, being real careful to point my torch outwards, not into the door, so I don't get any warpage in this area. Now all that's left for me to do is to weld the horizontal section back into place. For that, I don't have to hammer weld it. Another method of welding the patch panel to the door skin is by using the step flange method. I'll use these two pieces of metal to demonstrate how it's done. After all the rust is trimmed away from the door skin, I put a step flange in the patch panel. Insert it underneath the door skin and plug MIG weld holes all the way across the step flange. I'll use this tool on the end of an air chisel to put the step flange in the patch panel. You move it from side to side as the air chisel goes. I found it's better to put the step flange into the patch panel rather than the door skin because the combination of the air chisel and step flanging tool can easily warp the unsupported door skin, especially when you get out in the middle there, it starts flopping around. You've got to take the patch panel and securely clamp it to a work table in order to put the step flange in it. Also, in your patch panel, when you trim the height of it, allow a ½ inch extra for the height of the step flange. I'll demonstrate how to put the step flange in the patch panel right now. You could also put this step flange in the patch panel with a bead roller. Another way of doing it is with a special pair of vice grips that one company makes. I've drilled and deburred 3/16 inch holes along the door skin, 5/16 of an inch up from where the cut line is. I'll clamp the two panels together for welding. You always want to weld these two panels from the center out. Now, if you've got a panel spot welder, you could also spot weld them instead of MIG welding them. Another method that you could use is by plug brazing the holes, but you can get a lot of warpage up in here. You got to make sure that you cool the weld with compressed air. You don't use water because water will get trapped up in here and start rusting. Okay, I'd like to show you how I plug weld these holes with a MIG welder, but the welding light from a MIG welder is much too bright for videotaping and it would burn the camera. You've got to put a solid weld from a ½ inch in all the way to the edge of the panels. So when you fold the flange over, it won't split right here where the two panels overlap each other. This is what the backside of the step flange method looks like. Obviously, this method of welding is faster than hammer welding. There are drawbacks though. If plastic filler is used to cover the seam, it'll eventually crack right here. This will be due to panel flexing, which will be caused from extreme temperature changes, hot to cold, winter, summer, etc. If you live in a northern climate, this could happen in as much as 6 months after the repair is done. If you live in a warm, dry climate, it might take 5 years for it to crack. The correct way to cover the seam is with body solder, commonly referred to as lead. However, unless you're real good at paddling lead and using a torch, you could easily warp the two panels where they overlap, right here. It's real hard to metal work two panels that have been overlapped and are warped. You could use a heavy-duty soldering iron to make the lead flow, but it takes forever to get the two panels hot enough for the solder to melt. Don't let me discourage you from using the step flange method of welding. It's the most common technique used when doing this type of repair. However, for me to get the quality I prefer hammer welding. Hammer welding, properly done with good weld penetration, can be treated as if the metal panels were one sheet of uniform thickness sheet metal. The methods I've shown here for installing this patch panel can can be used to replace almost any rusted section of a car. It took nature 26 years to destroy the lower section of this door. It took me 12 hours to replace the door with new metal. Fix it the right way. In order to keep the rust from coming back, besides the zinc chromate, you might want to put undercoating in there. Make sure you replace the sound deadener that was in there to keep road noise out. Use metal prep to metal etch the door before applying body filler if you need it. After primer and paint, this door will look and fit perfectly, the right gaps all the way around.